Hey, hello everyone. Welcome back to the channel. And we are in day 6 of free Kubernetes series. And we are going to learn today about Helm charts. In this 20 minutes of video, you are going to learn from A to Z of Helm. And I'm going to take the complete responsibility for making you understand the Helm charts in a very easy way. This is my guarantee. If you don't like this video in the next 5 minutes, you can give a dislike. If you are liking this video, you can hit a like and share the channel link with your friends. So with that said, I have created a document on the Helm charts, but I'm not going to use this document. I'm going to explain you everything on the practical experience that I have from various companies. Now, you need to understand whenever we are talking about Helm charts, the first and the foremost things we have to take it in a very knowledgeable understanding. I hope you know about Yum. I hope you know about APT, right? I hope you are aware of DNF, right? So these all are package managers, right? For your software installations, for your software installations onto your Linux servers, right? Now, what will happen? Suppose Yum, you are going to use a CentOS software. Suppose APT-DNF, you are going to use Ubuntu software, right? In the same way, for deploying anything on the Kubernetes cluster, right? In the form of a package, right? You are going to use the Helm charts. Again, I am repeating, anything you want to deploy on the Kubernetes as a package, you are going to use the Helm charts. For example, I'm going to tell you in a very simplest form of explanation. Let's take some other page here. Okay, so let me take another page to explain you why actually the Helm is needed. Why Helm is needed. That is important, right? Now, for example, guys, what was happening, right? A DevOps engineer is there. He's trying to deploy his application onto the Kubernetes environment. Let's say he has 4 environments: dev, QA, stage, and production. Now, what was happening? Every time, whenever an application is deployed onto any environment, there will be some configuration related to environment. Okay. So let's say like I'm going to deploy in dev, there will be different configurations, QA, different configurations, staging, different configurations, and production, different configurations, due to which handling and managing the Kubernetes application deployments was becoming little bit difficult for DevOps engineers. Okay. So what the engineers did was, why not we use a Helm, which is helping us to manage the configurations, which is helping us to manage the deployments, which is helping us to manage the entire packages of the application deployment formats, right? Now, for example, if I tell you there is a DevOps engineer who has used the Helm charts to deploy his application onto dev, onto QA, onto stage, and onto production. Now, with one single Helm chart, having variety of configurations attached to it, he can able to deploy the same application onto dev, QA, stage, and prod. So you need to understand the first benefit is configuration management, at the same time deployment easiness. At the same time, for example, in the Kubernetes cluster, I am going to deploy an application as pod 1. I am going to have one more application as pod 2. I am going to have one more application as pod 3. When we are trying to deploy any kind of applications onto the Kubernetes cluster, these are individual deployments. And we deploy, let's say this pod 1 is an Nginx pod having a Nginx folder. Inside this, there is deployment.yaml file, there is service.yaml file. Till in the last hands-on also in day 4, you would have seen this. Let's say this pod is Walmart's pod. Okay, and it has also its configuration files related to its deployment services and all. And the pod 3 is another pod which is having different kinds of templates with it. But let's say like this, I want to deploy all the three in one go. So here your Helm is also helping you to deploy all the applications with one single chart. Very beautiful, right? The concept is. So here, how many times you have to deploy? Let's say I have to apply kubectl -f, oh sorry, kubectl apply -f pod1.yaml, correct? Same way, kubectl apply -f pod2.yaml. And similarly, the third one is kubectl -f pod3.yaml. But with the help of Helm, the folder structure of the Helm is helping us to deploy all the three pods, three applications with different configuration in one single core. Let's see what are that. So in Helm, you will get a folder structure kind of this chart.yaml, a charts folder, then you have your templates folder, and then you have your values data. Now, what will happen is this chart.yaml has the chart information. Okay, this charts has the dependency. Let's say like this chart is used to deploy these three pods. Under the templates folder, I have subfolders pod 1, pod 2, pod 3. Now the beauty is under the pod 1, I will again have different kinds of files, deployment.yaml file of pod 1 application, values, oh sorry, service.yaml file of pod 1, ingress.yaml file, config-map.yaml file. These all are related to pod 1. And similarly, under pod 2, I will have the same set of data. Pod 3, I will have same set of data. So this is called the ability of the Helm charts to deploy multiple applications in one single go. For example, this pod 1, pod 2, pod 3 are dependent on my pod 4 chart also. So this chart is used as a dependency chart. Similarly, like your pom.xml, there is a Java application and you have a pom.xml. In this pom.xml, you write your dependencies. In the similar format, you have your charts, which is equivalent to your dependency. Values, what will happen is, let's say I have a dev.value.yaml file, qa.value.yaml file. So this values store different kinds of key value pairs where your values are stored. And this key value pairs are dynamically passed to your configuration files, right? So that is the beauty of Helm charts. Not only this, if I take you into the little bit of depth, the Helm is similar to your, you can consider like your Git also. You have Git init, you have, sorry, Git pull, you have Git push. Similarly, Helm has also Helm init, Helm pull, Helm push, okay, and various kinds of Helm commands, Helm create, some Helm chart name. I'll show you the slides also. You don't need to worry about anything. So similarly, whatever you are able to do with respect to your Git, similar like that only. Now you need to understand how we had the Git and the GitHub repository to store our code. Similarly, you have a repository where you can store your charts. This is called Helm repository. You can pull your chart, you can push your chart, you can store your chart, and you can do all the different things that is needed for your chart to work. Apart from this, once your Helm is installed, let's say this is Kubernetes cluster, you have installed your Helm onto this. Now, the beauty here is once you have installed the Helm, now there are two versions of Helm now, 2, 3, and even 4 is coming soon. In the 2 and the 3, the major difference was the 2 was having the tiller format of deployments. Now, what this tiller was doing is once you install the Kubernetes along with Helm, this tiller was installed in the kube system namespace. Now this tiller will manage your Helm charts inside your Kubernetes cluster. Helm charts in format of releases. Okay, very beautiful. Now releases are nothing but, you can consider when I am doing a Helm install, it is actually a Docker run kind of a command, which is giving me a container. In the similar way, the Helm install will also create a release on my Kubernetes cluster. And you can consider like an instance, or in order to, I can say like an instance of Helm release, which will hold my data for that particular Helm installation. Right? Very simple, guys. No need to bang your head. I'll show you some slides now. Why Helm charts? If you are able to see the same structure I have told you without Helm, if you are able to see a DevOps engineer, a set of Kubernetes files, and different kinds of Kubernetes files have different kinds of configurations, production, staging, dev. But when the Helm has come in, there will be a common Helm chart where you have your production values.yaml file, staging values.yaml file, and your dev values.yaml file. And whatever the other Helms are there, which are going to use that common Helm chart, the deployments becomes easy. It's kind of a parent and child relationship you can consider. Not only this, as I have told you, the Helm is a package manager which contains all the deployment files together. Let's say I have a nginx deployment.yaml file, service.yaml file, config.yaml file, secrets.yaml file. All these deployment files, the Helm chart will hold together. As I have told you, configurations are also involved. Releases are nothing but whenever you write Helm install, right? Whenever you do a Helm install, there will be a release created in the Kubernetes cluster to track that chart. It will help you in terms of deployments. Now, if you see here, when we are talking about the Helm flow of architecture, very, very much important. I have to touch base on this particular concept, which will help you to understand the next set of things in the hands-on, which we are going to do tomorrow. Now, if you understand, in the Kubernetes cluster, there are variety of resources, correct? There are pods, there are deployments, there are namespaces. There are custom resource definitions. There is Istio, there is Ingress, there is network, there is storage. Now, when we are doing the Helm install, right? I told you the Helm is a package manager. It will have all the packages related to one software. Software is nothing but a pod. Inside that pod, you have deployment.yaml file, a values.yaml file, all those things, right? Now, let's assume that how the Helm will know, how the Helm will know, how the Helm will know that it has to run in which order, right? So everything is a resource. Under first pod, you saw deployment values, secrets. Now, how Helm will know that which it has to run the first order? Now that is where Helm is telling the order also. First, it will create a namespace, then resource quota, limit range, pod security policy. Anyways, pod security policy is not there in the Kubernetes latest version. Secret, config map, storage class, persistent volume claim, service account, custom resource definition, cluster role, and finally the API service. So this order of execution, the Helm chart follows whenever it has to create a architectural pattern. Very, very much interesting, right? Now, if I go ahead a little bit, okay, so you will be able to see that what is the next step that we are going to follow in our understanding. So these are the Helm commands, guys. Helm create, some name you give, creates a chart directory. Helm package packages a chart. Helm lint runs the test cases to check if the chart is correct or not, whatever you have written. Helm show all, inspect a chart and list its contents. Helm show values, Helm pull, Helm pull, Helm pull, Helm pull, different kinds of data points as the arguments you write it. Helm dependency list, you will check the dependency. In the chart folder, Helm install, the chart name, Helm install, chart name in the particular namespace, Helm uninstall, Helm upgrade, Helm rollback. So similarly, like your Maven install, Maven upgrade, right? Maven rollback, or any kind of things. Not Maven rollback, by the way, like you can do the rollbacks with the help of the Jenkins 5 pipeline with help of Maven also. But here you see Helm rollback. You can roll back your deployments into any kind of release version. Helm repo add, Helm repo list, Helm list. So these all commands are helping us to create the entire Helm deployments in a very smooth way. I can install 100 pods with one single Helm chart, because under the template folder, pod 1, pod 2, pod 3, pod 4, pod 5, similarly pod 100 has the capability to go over the data. Helm get all releases, Helm plugin install, and you don't need to worry, guys, because Praveen is here tomorrow. Hands-on, we are going to do from scratch. And I'm going to teach you everything from basics, so you don't need to worry. So if I go ahead, if you see, as I have told you, in the earlier times, you will have a deployment file, you will have a service file, where we have done in the day 4 hands-on, right? So when you are using the Helm chart, the entire folder structure of this one, right? This will be like deployment.yaml file, service.yaml file will be coming like this. Okay. Under the templates, you will have, because this is one pod only, everything is under one pod. But let's say I have two pods. So this will be pod 1. Under this only, I can have one more thing, pod 2, pod 3. And you can see here values.yaml file. This is the normal traditional deployment pattern, where you have a folder. Under that, there will be all deployments. But here it will be a little bit different, because this is how the data points are written. Now, if I still go ahead for making you understand, guys, the beauty lies in the tomorrow's hands-on. Okay, so stay tuned for the tomorrow's hands-on. Helm, nothing more important. We will do the CI/CD integration with the Helm also, in order to make sure that you are understanding whatever I am telling in a very easy way. So follow this Kubernetes series, share the channel link with your friends, and subscribe to the channel and hit a like, so that your friends will also know that someone is teaching. Okay, so this is Praveen signing off from this video. We will meet in tomorrow's video. Day 7 is your hands-on. So until then, stay tuned and comment down if you have any queries with respect to day 6. Until then, take care. Bye.